Before we move into solving more complex polynomial equations, we need to learn a handful more skills that will help us with the more challenging problems. So now we're going to get into what's called the remainder and factor theorems. And of course, if you remember from your third grade math, the remainder comes from division, and more specifically from long division. And so we're going to talk about how to divide polynomials through long divisions and other methods. So if we look at an example here, I've kind of got this little if-then statement where if we FOIL these two factors, these two binomials, x plus 2 and x plus 2, we come out with the trinomial. We know this is a perfect square trinomial. Now, if we were to reverse this process, if we were to divide out an x plus 2 from that perfect square trinomial, we'd be left with the other factor of x plus 2. Well, the way we've shown this in the past mathematically that you probably briefly looked at in Algebra 1 is what we call a rational expression. And if you recall, from a rational expression, you can divide out the like terms. And so we have an x plus 2 on the top and an x plus 2 on the bottom, which means we can cancel those out, leaving us just with the x plus 2. So all of these are really the same. The division of the x plus 2, either in a horizontal format or the division in a rational expression. Well, we can also do that method in a polynomial long division. Now, just to refresh your memory, set up a long division problem here that takes you back probably to your elementary school days. And if you remember, we don't divide out. We'll start here with the 25 divided by 3,025. We don't try to divide the 25 into the whole thing. We do it a piece at a time. And so what you recall here is we want to see how many times will 25 go into 30. And I know that'll go into 31 times. So then I'm going to multiply 1 times 25 to get me 25. Now if you recall here, we need to subtract the 25 from the 30. So even though I have a 25 in here, it's understood that we're going to subtract that, leaving us just 5. Now, we need to drop down the next term, which is the 2. And if we can, we see how many times 25 will go into 52. And so that would be 2 times. So 2 times 25 is going to give me 50. Again, I got to remember I'm subtracting that particular number, leaving me just a 2. And then lastly, the 5 dropping down. And 25 goes into 25 one time, leaving me 0. Now, this is a very important part because you can see here the remainder is 0. So the 25 goes in evenly or perfectly into 3,025. So in essence, the 25 is a factor of the 3,025. And so that's where we're going to start with polynomial long division. We're looking to see if this is actually a factor. And we'll get into that when we get into the factor and the remainder theorem. So for right now, we just want to learn the process of polynomial long division. So what we do is we start with this process, and I know it's all completed for us. I'm going to try to walk us through a little bit at a time. I got to think to myself, what do I want to multiply times this x to get x squared? So that's really my first decision, and I know that that gives me an x. So I'm going to multiply x times x, which is going to give me x squared. I'm going to multiply x times 2, which is going to give me a positive 2x. Now, that's where we would be. That's where we'd be in this process. Now, you remember, we need to subtract this. So technically, we're subtracting this whole binomial from the one above. And if you recall from a previous lesson where we were stacking these and we were subtracting them, we had to distribute that negative. So what ultimately happens here is this. We end up having negative x squared and negative 2x. Well, the x squareds cancel out, and 4x minus 2x simply leaves me 2x. So this is part of the process where you need to kind of understand how the subtraction distributes and then goes on to the next part. Now, I want to find out what do I have to multiply times x to get 2x, and that's going to be a 2. So so basically we're doing this, 2 times x plus 2. So 2 times x gives me 2x, 2 times 2 gives me a positive 4. Again, I need to subtract that whole thing. That's going to leave me with negative and negative. So if I subtract 2x, that cancels. The 4's cancel, leave me a remainder of 0. Now what this is ultimately going to tell me with the remainder and factor theorems is that x plus 2 is a factor of x squared plus 4x plus 4, which we technically already knew from our understanding of factoring of polynomials from previous lessons. But this is how we would find this out through polynomial long division.